Dimethylmercury 2Hg is an organomercury compound. This colorless liquid is one of the strongest known neurotoxins. It is described as having a slightly sweet smell, although inhaling enough vapor to detect its odor would be hazardous. Synthesis, structure, reactions. The compound was one of the earliest organometallics reported, reflecting its considerable stability. It is formed by treating sodium amalgam with methyl halides, Hg plus 2 Na plus 2 CH3I Hg2 plus 2 sodium iodide. It can also be obtained by alkylation of mercuric chloride with methyllithium, mercury 2 chloride plus 2 Lich3 Hg2 plus 2 lithium chloride. The molecule adopts a linear structure with HgC bond lengths of 2.083A. Reactions. The most striking feature of the compound is its non-reactivity toward water, whereas the corresponding organocadmium and organozinc compounds hydrolyze rapidly. The difference reflects the low affinity of Hg for oxygen ligands. The compound reacts with mercuric chloride to give the mixed chloromethyl compound, 2Hg plus mercury 2 chloride 2CH3 mercury 1 chloride, whereas dimethylmercury is a volatile liquid. CH3 mercury 1 chloride is a crystalline solid. Used dimethylmercury currently has almost no applications because of the risks involved. As with many methyl organometallics, it is a methylating agent that can donate its methyl groups to an organic molecule. However, the development of less acutely toxic nucleophiles such as dimethyl zinc and trimethylaluminium, and the subsequent introduction of Grignard reagents, has essentially rendered this compound obsolete in organic chemistry. It was formerly studied for reactions in which the methylmercury cation was bonded to the target molecule, forming potent bactericides. However, the bioaccumulation and ultimate toxicity of methylmercury has largely led it to be abandoned for this purpose in favor of the related ethylmercury cation, which perform a similar function without the bioaccumulation hazard. In toxicology, it was formerly used as a reference toxin. It has also been used to calibrate NMR instruments for detection of mercury, although less toxic mercury salts are preferred. Safety. Dimethylmercury is extremely toxic and dangerous to handle. Absorption of doses as low as 0.1 ml can result in severe mercury poisoning. The risks are enhanced because of the high vapor pressure of the liquid. Dimethylmercury passes through latex, PVC, butyl, and neoprene within seconds, and is very quickly absorbed through the skin. Much safety equipment used to prevent exposure to other chemicals does not provide protection from dimethylmercury. Gloves commonly used in most laboratories and clinical settings do not provide adequate protection from dimethylmercury. The American Occupational Safety and Health Administration advises handling dimethylmercury with highly resistant laminated gloves with an additional pair of abrasion-resistant gloves worn over the laminate pair, and also recommends using a face shield and working in a fume hood. Dimethylmercury crosses the blood-brain barrier easily, probably owing to formation of a complex with cysteine. It is eliminated from the organism slowly, and therefore has a tendency to bioaccumulate. The symptoms of poisoning may be delayed by months, resulting in many cases in which diagnosis was ultimately discovered, but only at the point in which it is often too late for an effective treatment regimen to be successful. The toxicity of dimethylmercury was highlighted with the death of the inorganic chemist Karen Wetterhahn of Dartmouth College in 1997. After spilling no more than a few drops of this compound on her latex glove, the barrier was immediately compromised, and within seconds it was absorbed into the back of her hand, quickly circulating and resulting in her death 10 months later. This accident is a common toxicology case study and spurred the development of modern advanced chemical protection clothing, which is now used when any exposure to severely toxic and/or highly penetrative substances is possible.